Hello, my friends, and welcome to the Bottleneck Guy podcast. I'm Clark Ching, and today I am chatting with a really good friend of mine, Robert Bolton. Robert lives in Sydney, Australia, and today he's chatting about his experiences of using the theory of constraints, ToC, in mining. Real mining, like holes in the ground, stuff like that. If you're coming to this from a background like I was, where you don't know much about mining, you're going to feel a little bit discombobulated and confused as the talk goes along. But then all will become clear as Robert fills in the details. And here's a funny little hint. It's not about digging holes in the ground faster. Enjoy! Hello, Robert Bolton. How are you?
Very well, Clark Ching. How are you?
I am excellent. It's lovely to be talking to you. You are in Sydney. I'm in New Zealand. You've been doing ToC, I think, since the early 90s, you said. Could you tell us a bit about that?
I have, and I've been involved in it pretty much since it's been formulated or particularly got out there. I came across the goal in 1990 as part of the operations management section of my MBA at Ashridge Management College. So for those people in the ToC community, they would be probably familiar with Alex Knight. Alex Knight was our operations managing lecturer, and he was very good. And at the time, we not only read the goal, we also operated some of the first simulators that were being developed by various people within the ToC community. And yeah, it was quite exciting. So in 1990s, when I first came across it, knew about the goal, and it was a significant part of the MBA.
And you've taken it from there. You and I know each other outside of podcasts, so I know how much you've done, and it's a lot. So it's pretty cool to have your experience here today. So I just want to focus in today, though, on the stuff you were telling me about mining. It's really quite interesting.
Okay, great. I'll start with a little bit about the mining industry, my direct experience, and then talk about where theory of constraints has helped create significant value and particularly certainty and stability within mining operations. The first thing about mining is, and particularly in the leading Western mining operations, so I'm thinking Australia, the US, Canada, and probably Chile, it's a very high value, high capital intensive industry, but also the people are very hardworking and they're time poor, information rich people. The thing about the mining industry is highly leveraged to the market, operational and financial inputs. And if you understand how they all work together and what are the likely constraint points, you can use a lot of the constraint management ToC tools to make a big difference of their mines. The mining industry has a lot of what I call natural decoupling points. So they will have a part up front called exploration. So that's people out drilling in the outback or in places looking for various minerals, and the geological guys know how the earth was created. They look at flow of the earth, flow of volcanoes, and in some segments, particularly gold and copper, they look for mistakes in the earth, and that's where they typically find these large deposits. So in places like Chile, Mongolia, Utah, and Nevada in the US, which are all big copper basin areas, they know that these rocks will have a certain amount of copper by just looking at them. So the key basic process steps in mining, there's an exploration phase. And then once they prove up, yes, we think so much of the valuable mineral is there in this particular area, they then develop the mine, then they go into the operational phase, and then and in the operational phase, there is really two key areas. There's the mining operation, and they could be underground or open pit. And then there's the processing operation. So just to put it into perspective, I first worked on a mine around about 1987, 88 when I was as a construction engineer, and later on as a turnaround consultant working in various mines. And one of the early ones was Argyle Diamonds. So I'll use the Argyle Diamond as an example of a mine. So Argyle Diamonds, which makes, amongst other things, the famous pink diamonds. So you'll hear about the Argyle pink diamonds. and very famous in the diamond industry. So the Argyle operation is a big mining operation where they're mining to look for diamonds, and that's big trucks, lots of explosives and lots of moving material. And when I was at Argyle in 1993, the approximate volume of materials was around about 120 million tonnes in waste. So that's put in, a big heap. 40 million tonnes would go as the input into the process plant. And at the end, they would get 39 million, and a pretty large number of tonnes would go into what's called tails, and they have all these tailings dams, and they would get 7 tonnes of diamonds.
Wow. What time period's that?
That's per year. That would be in those days, they were the production numbers back in the 1993. Got a lot bigger following the project I was involved in. But yeah, so you get 7 tonnes of product, 40 million tonnes of input to the process plant, and they would mine 120 million tonnes at the front end, at the mining area, to get the 7 tonnes of diamonds.
Wow. That's huge scale. I had no idea.
The other thing about the mining operation, throughout the places I mentioned before, very rarely are the mines near major centres. They're usually, in Australia, we call it the outback, it's out in the country. So Argyle is right at the top of Western Australia near the Northern Territory border, very famous for being hot. So when we were there, it was 40 to 45 degrees Celsius. Hot.
Wow.
And when we were there, which was October, November, it was just before the start of the wet season, and it was also humid. So very tough, trying conditions. You get the opposite effect in, say, Canada. So Canada's got a couple of diamond mines in the Arctic Circle. They have the opposite problem. It's very, very cold. So there you go. So there's 2 key processes. There's the mining side, separating the ore from the waste and putting the ore in front of the processing plant. And there's processing the ore through the process plant.
And this is kind of like you said, it's sort of naturally decoupled by these piles of ore that come out of the mine, and then they sit there, a pile of rocks, I guess, and then they go through the processing plant. Correct.
And the term that the mining industry would use is stockpiles. Whereas in the manufacturing industry, they don't always have stockpiles. And one of the things a ToC person would recommend is to put in stockpiles and buffers and control points at specific areas. The mining industry already had that built in because of the way it was designed, and because really the mining operation and the process operation are 2 different, very distinct processes. And that's the way it is. So there's a lot of information and a lot of value by understanding what goes on in the stockpiles and improving the stockpile information flow between the mine to the process plant.
The information flow there, not just the flow of the material. Okay, right. You carry on. This is interesting. I have pictures in my head here.
So one of the things that, as we've talked earlier, my background is civil engineering, construction engineering. The mining industry is a number of systems within systems, and the ToC people are used to all the systems. The big difference is the process plant is designed by chemical engineers or metallurgists to deal with flow of material with the chemicals and water and all sorts of ingredients to change the state of the material going through the process. So in the case of Argyle diamonds, it's 40 million tonnes of input to turn into 7 million tonnes of diamonds with materials of waste. At somewhere like a gold mine, you may get 100 million tonnes of input material, and they're typically working on somewhere between 2 ounces, maybe up to 15, 20 grams per tonne of output. So it's a big filtering process. A lot of areas having it. What happens, and my point right at the start was the information flows through a lot. The metallurgists who control the flow, who control all the parameters, have a pretty important bearing on what goes on. So one of the things I've found, because the mining operations and the processing operations are treated as two separate silos for all sorts of historical reasons, is that they don't necessarily look at the information that comes in the stockpiles and what to do with it. So, for example, another mine I was involved with, which was quite successful, and as a case study around it, which I call it throughput-focused mining, was Aluka Resources. So Aluka Resources is a mineral sand operation. So what happens at Aluka, they mine the sand, and in the mining operation, 90% goes back into the waste piles, or they reclaim the land, and 10% is what is called heavy mineral, and the heavy mineral goes into a process plant. The mining side can deal with a great degree of variation. The processing side cannot. And that's the simple principle. So the solution and the...
Hang on, let me just roll that back here, just in case it gets lost in the detail. That's a really important point, isn't it? That the mining has a lot of variation, but the processing plants don't cope with a lot of variation. So there's got to be something that shifts from one mode to the other.
That's right. And if you look at some of the buffer management principles that happen in other ToC applications, the same thing applies to the mining stage, where the high variation part of the business, i.e. the mining, puts it into stockpiles or buffer points. And so the mining guys can then process it in an orderly fashion to get the right quality, the right processing rates, and the right output or throughput doing that. So there is very distinct differences between the two. And the fundamental difference is the mining side is a series of mobile equipment which moves all around a very large site, whether underground or open pit, whereas the process plant is a fixed structure of some description. So it'll have tanks and water and kilns and crushers and conveyors and all sorts. So a lot of people see the processing side, think it's, well, what does that do? Explain to people the process the minerals to get some degree of good product at the end, be it gold bars, be it mineral sands, be it diamonds, be it clean coal, all the same sort of thing.
So that's the layout. That's what it looks like on a mine. You go there and there's holes in the ground somehow. There's piles of stuff that have come out of the ground, and then there's processing afterwards. And the stuff on the left of that, in my mind, is high variability, lots of moving stuff around. You said that I can get that, but the other side is like a fixed process. Yeah, okay, cool.
Yeah, and one of the important things is the chemical engineers, the metallurgists in the process side. So if you think of a left and a right in a flow, so the material's going from left to right. On the right-hand side in the process flow, the more detail they know about what's in the inputs, the more they can control the process.
Right.
Okay, and they have the ability to turn things up and turn things down if they know what's coming. And because the mining guys, who are typically driven and their prime measure is units per tonne, they will just dig holes in any order which suits them and then put it on the stockpiles.
Okay, so there could be a disconnect there. Yeah.
Well, there often is in the operations, and typically because of the historic reasons, and it's largely because of how mines develop and how when they're first created, there often is a disconnect between the two. And so the connection point and the decouple point, and I think the ToC term decouple point works really well, is you basically say, righto, these stockpiles we can have, and in the case of one particular gold mine I'm thinking of in outback Western Australia, they had 20 to 30, 100 to 500 tonne stockpiles and put in a particular grid pattern based on hardness of rocks, type of grade, and different processing characteristics. And the process plants can just grab what they want, put through the processing plant in a particular way, so they have less variability of input and greater control of the process. And so the scheduling, so there's two lots of scheduling of the inputs into the process plant, which is on the right side, and there's also the mine. What order do they mine or dig the holes or dig the ore to put in and to fill the stockpiles? So the stockpiles can become like replenishment points using the ToC replenishment solution.
Okay, so can I just sort of play this back? So I've now got a processing plant, and it's sitting there. It's a bunch of crushers and machines and conveyor belts and smoke and all sorts of stuff. Tanks of stuff, and
lots of smoke,
lots of smoke. Yeah, so it's sitting there, and I can picture now this, and then somewhere in the distance there's this hole in the ground, or there's a whole lot of earth being dug up, and I'm guessing. I think what you're saying there is that if you look at the order that you bring the raw materials in and process them through the factory, you could do that a really stupid way, which makes the factory very inefficient, or you could be clever about it, and the order that you put stuff through would make it far more efficient. And the bit that you do that is using the stockpiles to give them flexibility about what order they take stuff through. Is that kind of high level right?
You've got the high levels right, and the order of processing through the processing plant typically determines the throughput of the whole operation. And by whole operation, I mean the exploration, mining, and the processing. And the front end, the front third of the process, is usually where you'll find the constraint, because of the way chemical engineers design it.
Okay.
So if you think of the processing plant like a factory, there's a lot of similarity. Yes.
Okay. Yeah. So you got this. Yeah. You got this kind of this factory in the middle of an Australian desert, and the first bit of this is the bit that's normally the constraint, and then after that, it's got more capacity afterwards. Is that what you said? Typically.
Pretty much.
Okay. Why is that? Why is that?
Typically, the first part of a process will involve some sort of crushing or taking the ore from a bigger size down to a smaller size, typically from a rock or a small pebble into a powder. That's highly energy dependent and highly dependent on what the input is. In other words, what is in the stockpiles. Crushers by nature are a highly they're an abrasive, a very energy-intensive business. People have seen little crushers on the mines; they're usually quite big. So that is a key process that will drive. They will then have a series of screening or particle-sized loops. So before it goes on to the next part of the process, so in a case of a gold mine, they will have a series of cyclones, and cyclones are devices which spin the powder, the crushed up ore, with water or water and some chemicals to say, righto, they're small enough now they can go into the tanks and settle, or no, they're too big, go back to the crushers. And some operations may have 1, 2, 3, 4 different crushing circuits. So you just think the rocks may start off at 100 millimeters diameter, then they go down to 25 mils, down to 5 mils, and down to 2 mils.
So the front end's kind of heavy, expensive, fixed, sort of big, expensive processes, and then it's taking this big chunky stuff and making it into little small stuff, and then but why are the steps afterwards got more capacity than the front end? Is that deliberate design or?
Not always, and it doesn't necessarily have more capacity, and it will depend typically on what the design of the mine was originally.
Okay. Yeah.
So it's no hard and fast rule. On the back end will definitely have more capacity than the front end. It's just the front end is usually the driver to get the size down to an area to go from a mechanical process to some form of chemical process.
Okay. That's really interesting. Yeah.
Yeah. So in the case of gold, they go from a crushing process into a chemical carbon in pulp process. The carbon in pulp process is how you separate the gold from the other minerals in the ore. So just remember, you're getting the size of a 10-cent piece in a normal office size room of rock.
Mm-hmm.
That's the ratios.
Oh,
so
wow.
there's a whole heap of things happening there. Very much similar in the diamonds, the mineral sands, and coal sectors, where the first part is crushing and the sixth part is getting out the right level of material.
Okay.
And that's a yield measure. And the process plants are very much looking at high yields to increase the overall throughput of their material.
Okay, that's good. So can I just play this back, because this is really I'm just trying to think that the so when you do this that or hang on, do you? I presume they pull stuff out the ground typically at the rate that that they can actually process it, and then they put stuff in stockpiles of different bits and pieces, and then you were talking about the information. So then they go back, and if they look at those different stockpiles, they can then figure out how to cleverly coordinate it or put it through the factory in different orders. That sounded really quite clever.
Correct. Yep. So and they can do that, and typically in the Australian mining scene, they will have done a series of tests or geological tests on the stockpiles as the material's full, and they can say, righto, that material will have a hard, so in a gold mining case, or diamonds, they will say this material has a hardness of X, and we think it'll have a grade, and a grade is the amount of good stuff per waste. So it's a ratio of good versus a good in the waste. So in a low grade gold mine could be 2 grams a ton. A high grade gold mine would be anything above 15 grams a ton.
Okay.
So they know the different grades. And if they want to say, right, if we want to get the average output or over a period of time, and it's typically a month or a quarter, we want to get so much gold out, we take a mixture of the hardness, which takes longer to go through the front part of the circuit, and the grade, and we can blend it up front. So typically mines and in definitely worked at Iluka, and also the gold mines I've been involved in, where you develop a blend plan, and a blend plan becomes like, here's you managing the constraint through the schedule. So sometimes the constraint may not be in the crushers. It can be in the second part of the process, which was the situation at Iluka. So in the case of Iluka, the first part was sorting the mineral sands into the different chemical components. So those with titanium or different levels of titanium would get graded a certain way, and the non-titanium would go out into the different circuit. And then once the titanium mineral would go through a big kiln, and the kiln would basically heat the titanium over about an 8-hour period to get rid of the iron. And then they would get iron that they didn't need as a final product. So, there's a lot of different combinations. And typically the engineers and the metallurgists know how it works. What they're not used to is looking at saying, well, if you, Mr. Miner, mine things in a different order, we can get a big jump in total output capacity. And my experience has been it's a minimum of 10% and can be anything up to 40 to 45% increase through the same asset or the same processing plant with little or no additional capital to do it.
Wow. Okay, and that's just information, analysing it, and I don't mean just to put it down in terms of like a small amount of stuff. You're effectively saying, look, we go to that point, we understand what is there that gets our information, and then we just coordinate things differently, and so it becomes just a clever scheduling problem.
Correct.
And you get 10%, did you say, to 40% increase in output or throughput?
In throughput. Well, it can be both throughput and output. So I just need to go on the difference.
Yes, would you?
between in throughput and output. Output is the physical number of tons that go out the plant. So the mining industry will typically use that. Throughput, which is a really good measure, is the value of the material that could have a quality component. So if we talk about gold, if you get a higher level of gold through the process plant, that means that there's more value on the gold. That's not a big determiner. In other minerals, particularly mineral sands and, say, iron ore, if you get the grade through, so in other words, the processing plant, what comes out at the end that meets a very narrow specification, the customer will not pay you more for that, but they won't discount the product because you're not out of spec. So, for instance, what had happened? So what happened at Iluka? They got the spec so well in to the final product that they were no longer getting discounted by their customers, which were typical chemical manufacturers like DuPont and Huntsman and these sort of people from the US. So they and that was typically 5 to 10% of the value of the orders or the particular order between the two. So understanding the difference between output and the throughput with a quality component makes a big difference in mining in most mining operations.
And we must be talking millions a week here or a day even. Are we for this kind of work?
Most mining operations would be a minimum of $1 million revenue per day. They're getting a lot bigger now. They can be up to 10. In the Pilbara, the Western Australian guys, I think they're towards the whole operation, something like $150 million in product that goes through various parts of the whole supply chain. But a small mine in Australia will have 150 to 300 million turnover. And that sort of benchmark number is pretty consistent between the US, Canada, Chile, Australia, and other places like that. So it's big bucks pretty quickly.
That's really...
And once again, those people that are managing these assets have got to make a lot of quick decisions knowing that this is a $20,000 to $1 million decision over a 12-month period, depending on what decision that will make. So anything that helps their information flow is a big deal.
Yes. Yeah, that makes good sense. Wow. Okay. So can I just wander back, remembering that I'm a bit slow here, and just gonna see if I can summarize what you've said. You've got, when you do mining, you've got two different pieces, two major bits in the processing. One's getting the stuff out the ground, and the other is processing it. Now, the first thing that I heard that was really interesting there is that if I'm busy digging stuff out of the ground, I might be doing that. I'm not really taking into account normally the best order to do that for the processing. I'm doing it for the best order, I presume, to get stuff out the ground. And the bit that the first bit that sort of sorts that out is these stockpiles where we put we have piles of stock all lined up, and that decouples the two operations, and it allows you to get clever about what order you put the work through from the stockpiles into the processing, and that simple act of thinking and analysing and changing the order and scheduling and coordinating gets you more throughput.
Correct. And the two things to remember with the upfront or the first process or the one on the left, which is the mining operation, the mining guys have a lot more flexibility because they can bring in more equipment or have a lot more equipment or dig different orders. Their limitations is where they think the ore is in a particular mine pit, and there's a whole system of designs around that. And what they will be able to do is determine what order and where they dig in what order, depending on where it is. But you can't dig 10 metres below a block of dirt because you've got to move the 10 metres above it. So they're doing a lot of scheduling, all the rest of it. And their prime measure is typically a tonnes per cubic metre moved of ore and waste. And they've got a lot of metrics and all the rest of it. But you can, and often they don't want to do it, but you can get the miners to put their ore in stockpile situations to make it easier for the process plant. And that's a big issue. But once again, very smart people. The mining guys they could have 50 pieces of Caterpillar or Komatsu equipment running around an open pit mine, and that's 50 people as operators plus another 50 to 60 doing maintenance and other areas. So there could be 100 people working in a typical mine.
Wow, okay.
Just on that heavy equipment.
Okay, can I just reflect on this, just sort of take that, because it's really interesting. It's a whole new world I didn't understand anything about. Now I understand a little bit about it. I'm just trying to think I like to understand things by analogy, and I'm just reminded that my dad, he used to deliver stuff to building sites, concrete blocks and all sorts of different stuff. And he said that one of the things he always did when he got there is stopped, and before he took these pallets of whatever the material was off the truck, he'd have a look around and he would try and see where they were working so that he could take the stuff off and put it in the easiest order, so that it made the jobs of the builders and the bricklayers much, much simpler. And that's kind of vaguely analogous to what you're talking about, just getting the things in the right order so it's easier and then it gets more work done. And the other bit that jumps out at me is in the software world, and I know it's not just software world that does this, like the daily stand-ups, where you stand and you look and you see what's going on and then you coordinate the work. And often that coordination it almost looks really simple and easy, but you can get a lot more work done if you actually look and think about how can we coordinate this better. So that's just me letting that sink into my head. That's been really interesting, Robert. Thank you.
Thank you. That's good. I'll just add that most mining operations will have a daily stand-up at the beginning of the day, which is usually around safety, because they're very conscious on safety, and adding a quick priority, what our plan is for the next day, the next 3 days, and the next week can add a lot of value about what they're going to do. So it's usually the supervisor will have two agendas first thing in the mornings, and the meetings go from 10 to 20 minutes, depending on what's going on. And it's exactly that. We'll say, here's all the safety things, and they'll go through and there'll be information going out there, and usually the guys have got something to read or whatever. And then they say, here's what the schedule is. And having a rolling schedule makes a big difference. The other thing that I will add to that, and you're right about your father putting the materials for the builders, it makes a big difference. So in the processing plant case, the stockpiles are the staging point, and that will be in a rigid place,
right?
In an operation. For the mining guys, that can move around a big hole in the ground, depending on where they're digging and why they're digging. So when you're on a mining operation, you go down the pit, say once a week. I can spot the differences. What's changed in that last week? There's a new hole here, or they're digging over here when they weren't there, and all the rest of it. So those holes take a long time to dig, and when you fly over a mine, you'll see, wow, how long did that take? They could be a long time. But that's all the right sort of analogy for the same reason. But getting the activities happening at the right order, the right time, where the people making decisions on, so I'm talking the chemical engineers and the mechanical metallurgists through the process plant, makes a big difference.
Really, I like that. There's so much more work you can get done by doing things that aren't the direct work, or the curation and the coordination, just talking together, all that kind of stuff. I find that fascinating, because a lot of people don't realize just how much. But you're talking in a big mining operation, better coordination, better talking, working together so that you're all focused on the same thing, 10% to 40% in an operation that is earning $1 million a day, roughly, is pretty ginormous. Hey, look, let's wrap it up there, Robert. That's been fascinating. I'll get this podcast out, and then I would love to talk sometime in another month or two, maybe about banking or something different. But that's been really fascinating. So thank you.
No problem. I look forward to it, Clark, and have a great day.
Before we go, just wanted to point out, see, I told you it wasn't about digging holes in the ground, Master, was it? Right. There's more to come. Bye.